everyone, welcome back to the Chemstrology podcast, powered by OnlyTRAININGS. I'm your host, Frank Harper, and today we're stepping into a manufacturing universe that most people don't think about, but literally interacts with our daily life almost every minute. Blow molding. If you're thinking plastic bottles, yes, but trust me, this topic goes deeper. Fuel tanks in EVs, drums for chemicals, oxygen containers in medical, and even storage tanks used in industrial operations. And joining me today is Mike, who has spent over 2 decades in blow molding formulation and processing. He's seen defects that would make any engineer question life decisions. So, Mike, thank you for joining us.
Thanks, Frank. Yes, I've seen blow-molded parts do things that even polymers themselves were probably shocked by.
Let's just jump straight in. Why is blow molding still so unpredictable even after all these years?
Well, Frank, blow molding is actually a very dramatic process. You take a molten tube of polymer called a parison, shape it by inflation, cool it rapidly, and hope all molecular chains align politely. Except they rarely do. So every mechanical property is determined in seconds, and if anything in formulations or processing slightly misbehaves, you get defects.
So basically, polymers like chaos?
Exactly. Polymers don't flow, they negotiate with you. You stretch them too fast, they trap stress. You cool too fast, they complain with whitening. You change additive package, they change behavior.
Okay, so here's something interesting. Manufacturers say they solve the defect only to see it return 2 months later. Why does this happen?
Because many times we don't solve the actual problem. We solve what we're seeing. Example, whitening. People may adjust mold cooling and think it helped, but whitening often comes from internal stress, high crystallinity, or improper nucleation. So, unless formulation changes, the root cause remains. We tweak processing, but the defect was formulation-driven.
That sounds like applying a Band-Aid to a fracture.
Exactly. Except polymers don't heal inside.
Where do we see the biggest struggles right now?
Well, I'd say EVs, multi-layer fuel systems, pharma containers, hydrogen storage. These applications demand thin walls and very high performance. Impact strength, chemical resistance, gas barrier properties. So suddenly, formulation becomes a science of compromise. Mechanical versus barrier versus sustainability versus recyclability.
That's a brutal balance to manage. Okay, Mike, tell me one big misconception about blow molding.
More cooling solves everything. Nope. Too much cooling makes polymers angry. Instead of relaxing into structure, they freeze stressed.
Polymers holding grudges again?
Some polymers have a longer memory than humans, I promise you.
Give us a real case story. What's the strangest failure you witnessed?
Well, we once had a storage drum collapse inward after installation. No processing issue, no external load, just literally collapse like someone sucked air out. Turns out, parison stretch orientation plus rapid cooling plus chemical exposure, plus slow creep eventually formed an internal vacuum effect. Took 2 months to reveal.
That's like polymer horror movie.
Exactly, except no jump scare, just expensive losses.
If someone listening wants to improve their blow molding results starting tomorrow, what mindset should they carry?
Think formulation first, process second. Ask questions like, what's my resin selection logic? Which additives support performance? What melt strength do I need? Is my MFI appropriate? How is crystallization controlled? And most importantly, characterize your part after production. Don't wait for failures to reveal themselves.
So instead of treating defects later, we predict them earlier.
Yes, and several failures are predictable if you understand polymer behavior.
Now, I know you're doing a practical session with OnlyTRAININGS soon, but it's more like examples and troubleshooting cases rather than theory, right?
Yes, real industry case studies. People love examples they can relate to. And of course, it's only 2 hours, so easy to join from anywhere.
Mike, thanks for walking us through such an overlooked but fascinating field. Honestly, this conversation has changed the way I look at a simple plastic bottle.
Or at least now you'll suspect every bottle you see.
Exactly. Thank you, Mike, and thanks everyone for listening. Stay tuned for more episodes of Chemstrology, and we'll see you next time.